Hello, this is checkpoint 6.9. They want us to know, or they want us to find out, if f of x, y, z is equal to x squared cosine yz plus y squared sine, or y squared z squared, is a potential function for the vector field 2x cosine yz, comma, minus x squared z sine yz plus 2yz squared, comma, y squared. For this to be a potential function, the vector field has to equal to the gradient of the function, which is to say that the gradient of the function is the partial with respect to x, comma, the partial with respect to y, comma, the partial with respect to z. So if these components match up, then we can say that little f is a potential function for the vector field capital F. Well, let's just check. Let's take this little f function, take the derivative with respect to x. The derivative with respect to x is going to be 2x times cosine yz. Cosine yz is constant with respect to x, plus 0, because y and z are both constant with respect to x, and the derivative of that is 0. Fy, the derivative with respect to y, well, we have to take the derivative of cosine yz. X squared is a constant, so we'll start off with x squared. The derivative of cosine is negative sine yz, and then we take the derivative of the inside yz with respect to y. That's going to give us a z, and then we have a plus the derivative of y squared z with respect to y. That is 2y. Z squared is constant, so that's just z squared. And now let's take the derivative with respect to z. Again, the cosine yz and its derivative is going to be negative sine yz. This time we take the derivative with respect to z. This is going to give us a constant y, and then the x squared was constant, so that just stays. And the derivative of the second term with respect to z is going to be 2y squared z, so it's basically 2z times y squared. And if we rewrite this, our gradient is going to equal to 2x cosine yz, comma, let's just rewrite this a little bit. Let's write x squared in z with a negative, and then sine yz, and then there's a plus 2yz squared, and then finally we're going to have negative x squared y sine yz plus 2y squared z. And if we check this, we see that we match the first component, and it looks like we match the second component. However, the third component looks completely different, and therefore this is not a match, so not a potential function. So f is not a potential function for the vector field F, capital F. All right, I hope that helps.